Good morning, or afternoon, or night. Probably not the best way to greet you guys when I have no idea when you're watching this. Anyway, moving on. Today we are going the distance. Distance formula, that is. All right. There are two things we're going to be talking about when it comes to the distance formula. The first that I'll be doing is if you have a graph, using the graph to find the distance between 2 points. And then later we are going to do, if I just give you flat out 2 points, like 2, 7 and 5, 4, find the distance between those 2 points. And while we do that, I'm just going to go ahead and make up an example right here. I'm just going to go ahead, put a point there, and put a point there. And my question is, what is the distance between those 2 points? Now, if I was to zoom in a bit, you know, it's not super obvious. You can't exactly kind of count right here. If I did something special like, what's the distance between this point and that point? This is an easy question because it is a straight line across. You can just go 1, 2, 3, 4, 5, 6, 7, 8, 9, and the answer is just 9. But as soon as you curve it like that, so it's not straight across or straight up and down, its distance is not necessarily going to be a good number. So how do you find the distance of a line that is not that kind of straight? And the answer is actually somewhat like a question we did in the last video I made, which was the Pythagorean theorem. What we are going to do is first of all go to a new one because that line is not straight and I don't like that. A little bit of OCD there. Let's go ahead and make this this line. And I'm just gonna use a paper straight edge to make it a bit straighter for me. So, there you go. From here, if we want to find the distance between those 2 points, what I am going to do is make a triangle. I will make a length right here and a length right here, and I have magically made myself a triangle. And since this is vertical and that's horizontal, it is more specifically a right triangle. And what we have learned before is that if you have a right triangle and you know this distance and you know that distance, you can find the hypotenuse. But like I said in this one, if they are straight from each other, you can literally just count to see what the numbers are. And I'm going to do that here. 1, 2, 3, 4, 5. So this distance is 5. 1, 2, 3, 4, 5, 6, 7. So that distance is 7 right there. And according to the Pythagorean theorem, this is A, this is B, and this is C. A squared plus B squared equals C squared. So I could do 7 squared plus 5 squared equals C squared. This would be 49 plus 25 equals C squared. And then just take 49 and add it to 25. I said add it to 25, and it looks like you get 74. So I'll go back here and say 74 is equal to C squared. So how do you make it just C and not C squared? It is square rooting. So take the square root of 74, and it's about 8.6. Which, you know, at this point, it's always good to just go back to the question and see if it's believable. Like, this is 7 and this is 5. It's believable that this is somewhere between 8 and 9. The reason you should always see if your answer is believable is because sometimes people forget to square root the answer. In which case, they'll say, oh, the answer is 74. Ha 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 ha. But if you look at the picture, if this is 7 and that's 5, what are the odds that this length is 74? Like, this right here is 20. 74 is, let me zoom out. This is 74. little tiny dots. So it's definitely not going to be 74. It's going to be a smaller number. So that's kind of your cue that you probably did something wrong. And then when you think I did something wrong, you can go back and see you forgot to square root it. And there you go. That's just what you do. So I'll go over here and I'll do another one. This time let's put a point here and a point here. And I'll do the same thing. I'll use this and go. There we go. And if I make this into a triangle, like that. You could also make the triangle over here. It does not matter when it comes to the distances. So you could, if you felt like it, do the triangle here. Don't think it's like, why is he doing the bottom one? It does not matter because just like the legs can switch with Pythagorean theorem, so can this little box. Like either way, you're going to get a distance of 2 over here. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 on the bottom, right? This would be 2, and this would be the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So either way, you get the 2 and the 11. So it does not matter. And same thing is going to happen. I'll have 2 squared plus 11 squared equals c squared. It's the distance we're looking for. You get 4 plus 121 equals c squared, which is 125. And then once you get to that, it's like, if you think this is the answer, you can say, well, this is 2 and 11. This is not going to be 100 things long. I'm sorry, 100 things long. It's just not big enough. If it's 2 and 11, square rooting this should get us something that's, more than 11, because the hypotenuse is always longer. But I'd be surprised if it was over 20. I very much doubt that. So square root of 125 is 11.2. So yeah, definitely believable there. This length and this length are, like, if you just think about it, they look like they're pretty much the same distance. This looks like the same distance as that, except it's a little bit longer. And sure enough, 11.2 instead of 11. Okay. Yeah, so that's how you do it when it's in a graph. What I would like to do is just make up a random problem, see if you guys can do it. And it's another one of those things where I'll ask you to pause and then see if you can get it right. So go ahead, pause, see if you can find the distance between those 2 points. Let's see. Okay. Those of you who know, I wear glasses, so I have to look really close. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. Okay. So this will be, if this is A and this is B, 9 squared plus 6 squared equals c squared. Then you actually square those. And then this will be 11.7 equals c squared. And if you take the square root of 117, you get about 10.8. So the distance is about 10.8, which, is more than 9, is more than 6, and it's not super unbelievably long. So that looks good to me. Okay, now what we are going to do is a distance formula. That is, if I was to literally just give you the ordered pairs, like if instead of this figure, I gave you the numbers -2, -3, and I was to give you this ordered pair, which is 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 7, 3. And I was to literally just give you these 2 ordered pairs, no picture whatsoever, and say, what is the distance? Right? you could plot these points and then do what I just did. That is a legit method. Sometimes you don't want to do that because sometimes math can get messy, and it's like, what if I said, well, what's the distance between 2, 5 and negative 400, comma 2.793? And it's like, I ain't graphing that anymore. So you do want a formula that uses numbers and letters and stuff instead of just plot it and do it. Because, you know, these ones you could plot easily and then just do what we just did. So if that worked for you, you can do it. But sometimes it's just not going to be possible. So we do want a formula. So the formula, I will not immediately show you because I do not like just showing people formulas. I like to explain formulas a little bit. The last time I showed you guys a formula had to deal with midpoints. So we had to talk about how do you find the length of something. And one of the things we talked about is that if you want to find the length of something, you subtract the numbers. If you've forgotten that, then let me just make a quick reminder for you guys. If you have a line segment, right here, this is the number 1, 2, 3. So it starts at 3. And this is 4, 5, 6, 7, 8, right? 3, 4, 5, 6. Oh, God. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9. That's the number 9. So if it starts at 3 and this goes to 9, then you would subtract the numbers to find that the distance is 6, or you can count 1, 2, 3, 4, 5, 6. So the distance is 6, but you would get it by taking the second number and subtracting the first. And that's actually what we're going to do in this formula as well. If you have also forgotten, when we have two ordered pairs, we call the first one x1, y1, which I'm going to write over here. x1, y1, and the second one, x2, y2, just for, you know, first and second. Zoom out a little. So this right here is the second one, and this right here is the first one. So if I wanted to find the difference on the x-axis, the second one minus the first one. So that would be x2 minus x1. That is this distance. That is this distance in this sample problem, you know. At the same time, we need to do something with that. Usually that is a, and then we would square it down here. So just like I would take this number and square it, like I would take this 6 and square it, we're going to take this and square it. And then we would do the same thing with what would be b, you know, the vertical. But with vertical, you use the y's, because y's is the up and down. So instead of x2 minus x1, we'll do y2 minus y1. And that's going to give us the distance that's vertical, the b. And just like before, you usually square that number. So we're going to square those, and they're being added together. So as an analogy, this would be a squared plus b squared, because this is the distance of a and this is the distance of b. And this would be equal to c squared. But in a formula, you never want it to be like, oh, do this formula and then you do more. Formulas you want to be, you do this formula and you're done. So normally the last step is to square root both sides, so that's just what we're going to do right now. And you can just say c is equal to all that stuff that I just wrote down. And that right there, ladies and gentlemen, is the distance formula. Dun, da, da, da. And now we get to do practice problems like that. So distance formula. The distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. If you don't believe me, you can Google it. Distance formula. There you go. And the proof. GG.